Hey there! If you're completely new to Python, machine learning, or deep learning, well, you are in exactly the right place. Think of me as your personal guide for this explainer. We're going to take what often seems like a highly complex, kind of intimidating topic and break it right down into simple, bite-sized pieces. By the end of our time together, you're going to have a really clear, foundational understanding of literally one of the most powerful tools in tech today. We're doing this step by step, together.
Okay, let's dive into this. How exactly can we teach a computer to recognize the faces in your photo album, or understand a completely foreign language, or even learn incredibly complex patterns from absolute oceans of data? You know, this is the core problem we face in artificial intelligence. We need a way to translate our messy, human world into a process that a machine can actually learn from. And that, my friends, is exactly where TensorFlow comes in. So here's our simple roadmap for today. First, welcome to TensorFlow. Second, tensors, the building blocks. Third, building a neural network. Fourth, training your model. And finally, number 5, the wider ecosystem. All right, let's get into it.
Welcome to TensorFlow, the complete toolkit for teaching computers. I like to think of TensorFlow as a massive, complete toolkit for teaching computers how to learn from data. Inside this toolkit, our tensors are just the containers holding our materials. The neural network layers are the physical building blocks we snap together, kind of like Legos. And training is simply the ongoing process of the computer actually learning from the examples we show it. At its core, TensorFlow is a super popular, open-source machine learning platform that's mainly used with Python. It is the absolute go-to environment for beginners and experts alike to develop, build, and train deep learning models. It essentially takes all that incredibly heavy mathematical lifting required for machine learning and wraps it up into a platform that we can actually practically use.
Now, I want to anchor you here on this workflow for a second, because this is the fundamental journey your information takes. It all starts with raw data. That data gets packaged up into our containers, the tensors. Those tensors are then fed into the structure we build, the neural network. Then the network goes through a learning phase, which we call training, and finally, it spits out a result, which is our prediction. Literally every complex model out there boils down to this exact pathway.
So why does all this matter? Well, TensorFlow gives us the exact tools to handle those tensors for storing and processing numerical data. It lets us build deep learning neural networks from scratch. It handles automatic differentiation, which honestly is just a fancy way of saying it does the insane calculus needed for training automatically, totally behind the scenes. It also allows for GPU acceleration to speed up massive computations. Plus, it handles the whole lifecycle, from model training all the way to deployment. This is exactly why it's the engine behind huge real-world stuff like computer vision, natural language processing, and even those recommendation systems that suddenly know exactly what movie you want to watch next.
Moving on to Section 2, tensors, the building blocks. Zooming into the code.
So, zooming in from the big picture down into the actual code. First things first, to use the toolkit, you got to bring it into your workspace, right? You'll typically install it using a command like pip install TensorFlow. Though, keep in mind, the exact way you do this might depend just a bit on your specific operating system. Once that's installed, we bring it into our Python code. We almost always import TensorFlow under the super common shorthand TF. We also import Keras, which, as you'll see in just a minute, is a fantastic high-level interface built right into TensorFlow that makes creating our models incredibly intuitive. Okay, and now we hit that word again, tensor. Please don't let this word intimidate you. A tensor is simply a multi-dimensional numerical container. That's it. It's really just a bucket used to hold and represent the data flowing through our machine learning computations. Whether you're working with an image, a sound wave, or just a giant spreadsheet of numbers, TensorFlow has to convert it into a tensor so the computer can actually process it. Let's look at a really beginner-friendly example of this in code. Right here, we're creating a tensor named x that holds a simple sequence of numbers using tf.constant. When we print x, we just see our numbers. But when we print x.shape, we're actually asking TensorFlow to tell us the exact dimensions of our container. Tensors can be just a single number, which we call a scalar. They can be a list of numbers, like a vector. They can even be a grid of numbers, like a matrix, or go into even higher dimensional shapes. The shape literally just tells us how our little data blocks are stacked.
All right, Section 3, building a neural network, assembling with Keras layers.
And this brilliantly illustrates our next step. Now that we have our data packed neatly into tensors, we start snapping those building blocks together into a structure using Keras. Remember, that's TensorFlow's high-level API. We're creating a sequential model here, which really just means our data will flow through it in a straight line, layer by layer. We add a dense layer, which is your standard neural network layer where all the internal nodes are connected.
We give it 8 nodes and an activation function called ReLU, which basically acts like a smart filter to help the network decide which signals are actually important enough to pass forward. Finally, we add another dense layer with just one node for our final output. And just like that, you've written the architecture for a neural network. No way, right? It's that clean.
Section 4. Training your model. Turning the machine on.
So building the network is kind of like building a sports car. It looks great, but it doesn't actually know how to drive yet. Here is how we turn the key. First, you prepare your training data. Next, you compile your model. This means you choose a loss function to measure exactly how wrong the model's predictions are and an optimizer to help it correct those mistakes. Then comes the real magic. You train the model using model.fit. As data flows through the network, it calculates its loss, updates its internal parameters, and actually improves its predictions over time. You monitor this, and finally, you evaluate the trained model on new data to see how well it truly learned.
Now, of course, learning anything new comes with a few bumps in the road. As you start writing your own code, keep an eye out for these common beginner pitfalls. Things like confusing your tensor shapes, feeding data with incompatible input dimensions into your network, or, a big one, skipping necessary data pre-processing. Sometimes beginners also pick an unsuitable learning rate, meaning the model tries to learn way too fast or way too slow, or they run into overfitting, which is basically when the model memorizes the training data perfectly but totally fails to understand new, unseen data. Just knowing these pitfalls ahead of time gives you a massive advantage.
And finally, Section 5, the wider ecosystem, zooming back out.
Zooming back out for a second, you'll see TensorFlow is a really massive, comprehensive environment. You've got Keras, which, as we just saw, is your primary tool for model development. You have TensorBoard, which is this incredibly cool tool for visually monitoring your model's training process. When you want to put your model on a smartphone or a tiny edge device, you use TensorFlow Lite. And to handle the heavy, massive math operations required for all those tensors, TensorFlow seamlessly integrates with GPUs. Those are specialized hardware pieces that provide massive acceleration to speed up your training. As we wrap up this explainer, it's really vital to place TensorFlow in the context of your overall Python toolkit. Now, libraries like NumPy and Pandas are absolutely fantastic. They are exactly what you use to handle and prep your raw data. Matplotlib and Seaborn, those are your go-to tools for visualizing that data with charts and graphs. But when it comes time to actually build, train, evaluate, and deploy deep neural networks, that is where TensorFlow and Keras step right into the spotlight. They are highly specialized tools built specifically for the heavy lifting machine learning phase of your project.
So TensorFlow gives you the complete platform to essentially mimic human learning in code. The power to predict, recognize, and automate is quite literally at your fingertips now. So I'm going to leave you with this. Now that you actually hold the building blocks of AI in your hands, what world-changing idea are you going to build next? Thanks for joining me for this lesson, and I'll see you next time.